Good morning, everybody. We started a little bit late. It's, I think, very understandable, but I'm happy to be here. My name is Jürgen Heinzel. I come from Amsterdam, and I work since more than a decade for UNStudio. And I'm actually quite happy to kick this off today. I would have hoped for a little bit more of audience, but I can understand the hangover. Quickly to introduce UNStudio, I mean, we are an international company active since more than 30 years. We work in a very broad field between architecture and product design, so we have a really wide span. And what we usually consider ourselves doing, apart from facing the architectural challenge, is that we actually try to challenge architecture. I have one question because I started my architectural career at the beginning of 2000, so I'm a little bit from, let's say, the older generation. What I usually ask to kind of test the temperature in the audience is like whether you can relate to that image on the screen. So if you can raise your hand, if you can understand that relationship, please. Okay, so it's like 50%, I would say. So you are old, unfortunately. For architects and engineers, there's a similar relationship. So could you raise your hand when you understand that relationship? 1, 2, so a couple. Great. Also here it's the same. You're unfortunately old. Today I want to discuss a little bit, or let's say my presentation today will be based on a conversation between Tim Melbourne from Made by Many, Oliver Marlowe and John Marshall. They had a very interesting discussion about the ways we design and also what we are designing for, because this very much relates to our own practice. We of course design for emergence. We have seen this already in the past. We have been designing a lot for complexity, but this is also very apparent because complexity is more and more increasing. We need to be adaptive nowadays, and everything we need to do in collaboration. So I would like to start from emergence. So it's quite clear that anything we do today, also looking at our own projects that we are doing, they're mostly spanning over like 10 years, 15 years, 20 years, depending on the scale and complexity. So you can simply not just expect that what you think of today will be kind of future-proof 10 years, 20 years down the road. So I think one of our oldest projects actually started in 1996 as a competition and as a master plan, and we just finished it 2 years ago. So there's a long process relating to it, and we need to be kind of aware of that. And then during the way, there's of course an invitation to interact. So there's a lot of interaction and modification needed, also looking at the markets. When you look at the market, it's not always very clear, and it's not always very understandable. What are the driving parameters that really kind of let you estimate and make assumptions for the future? But one thing that is always very apparent, what we noticed in our experience, is that mobility and infrastructure is one of our main focuses, but this is very, very emergent. It's there's a very high demand to make people mobile and also build the right infrastructure to accommodate this. So this is this project that I had mentioned before, which we started in 1996. It's basically a big transport hub in the city of Arnhem in the Netherlands, on the edge to Germany. So it's kind of a bit of a big node where a lot of things are happening in terms of transportation. So all the international trains are coming in there. There is buses that need to connect there. There's a lot of pedestrian traffic. So it's kind of a very big machine, so to say, of transportation that we kind of had to think of in a new way. So there are many components we had to combine and that we had to layer. So after we had intensively studied the passenger flows and also all the transport nodes, we actually proposed this new transfer machine, and so that we can really think, let's say, 20 years down the road in order to meet the demands of the 21st century. If you think of intuitive flow, so this is Shinjuku Station in Tokyo, it's not always very intuitive because there's a lot of information that you need to digest in order to kind of move through space. So what we believe truly is that architecture should kind of accommodate this people flow and kind of should facilitate a very intuitive way of movement. So this is basically our transfer hall in Arnhem. It's basically a column-free space. It's the heart of the project, and it kind of forms as an architectural designed expression. It kind of facilitates an intuitive movement throughout the space. So this allowed us really to reduce the wayfinding. So comparing to that image that you have seen before, which is simply just only wayfinding that you see, we managed to really facilitate by architecture and by the gesture in the way that people can move through space, and we were able to reduce the actual literal wayfinding by to less than 30%. So what this allows us is that we have kind of this seamless experience, and we give a seamless experience to the people. And what this allows us to do is that we can, at the same time, give the places and the space back to the people. So you kind of have that in the way how you organize the space, you really allow for kind of to create a platform for the people to basically give them a platform to interact with the architecture. So you will be quite surprised about what is happening in there. Same goes for our Mercedes-Benz Museum in Stuttgart, which was basically started as a company museum. And in the end, it turned out that, or in the meanwhile, they are hosting more than 300 events a year in this place. So it kind of had this kind of additional layer of function and functionality on top of what we had designed back then. Of course, we need to talk about complexity today. So you can actually say that in terms of complexity, it's quite an exciting time still to do architecture, to do design. And so there are many different ways of creativity, and it's of course increasingly software driven. But as we already heard today, or as is also kind of an underlying, let's say, argument about this symposium today is that this digital driven design process, they're not really kind of in the forefront anymore. So when we look at it, there's a certain convergence along the way. So where we come from. So when I still started to draw by hand. I bought one of those kind of drawing tables, which I had used for like roughly a month, beginning in my studies, and then I kind of turned over to the computer and used my drawing table basically as a base to build physical models. So our CEO, he used to say, okay, from the architecture point of view, we are kind of in the iPhone age. When we look at industry and we go to construction site, we every now and then kind of face people who are more kind of in the Walkman age. So that said, this convergence is basically turning around every now and then. So wherever you work, because we work very internationally, it depends what the technological standard is. But you mostly you need to be very tailoring for the local conditions, and you kind of need to comply to what is the actual building standard. So we have seen over the years many different standards along the way. So you cannot just always get through with digital and technology. Of course, there's also kind of a polarizing factor to it. So it also enables you to generate new technologies or adapt technologies in your home, in your living room, that might be a little bit provocative over time. There's a lot of hope for artificial intelligence, of course. I think there's Until we have solved certain things in AI, probably we will hear more about it today, whether we have solved the difference between fried chicken and labradoodles. But I think also there should still be a human notion to the way we work and the way we design. When we look at the drivers, just to give a little bit of an idea, when we start a project, we can come from a very broad angle, and of course every let's say contemporary architecture firm kind of has to take this broad approach to it. So of course you always have to develop a concept and a design. You want to be functional, you want to be innovative, you want to kind of please the audience or your client. You want to make sure that it's an efficient building, it's properly used, the post-occupancy is really in place. You create new business opportunities and so forth. So it's a very, very kind of big field of parameters that you want to consider. So in another question, you could also ask yourself how you want to eat an elephant. You would actually chop that elephant in little pieces. When we start our design processes, we always go through a process of resolution. So we start from mostly bold ideas, big details. So what is our main design objective and how can we further kind of give resolution over time? So when you look at the very, very first kind of concept for the Mercedes-Benz Museum, on the left, this was basically one of the first ideas, the first sketches, just basically on a plate. And on the right side, you see in what kind of complexity this turned out to be. The Mercedes-Benz Museum itself is a place where we actually combined certain elements in a single gesture. I have been talking about the intuitive flow. This is something that we very much kind of followed here in this principle, or in this organization of the building. It was kind of a new approach back then in 2002, if I remember correctly. But this building back then fascinated me so much that I had to start working for this company. So, and it still is. It's still one of the most fascinating buildings for me. What was the biggest challenge here, if you think about it, is the continuous flow, and you pair this with German building regulations. You kind of face hard resistance on fire life safety. So we have this central void where all the program is kind of weaved around the two strings of program. In the way you circulate through the building, you would constantly kind of move between the outer perimeter and the inner atrium. So there's a strong notion of kind of diagonal views and interconnection of spaces, and also understanding and orientation. The biggest challenge here was basically to not need to compartmentalize in terms of fire. So what we came up with, or what the team back then came up with, is basically to use the internal atrium as a funnel to, in the case of fire, you would try to extract the smoke from the inner space, to not need to do any fire shutters or smoke curtains that would kind of diminish the architectural quality. So I would like to play a little video, if it plays, just to show you how it was solved in the end. So this inner atrium basically has, which is quite important for the way how you get started into the exhibition. It's like you move upwards. So the exhibition itself starts top to bottom, and so it's a kind of, they call this the prologue space. So the before, when do you or how do you kind of get into the let's say cultural heritage of the company. And then at the very top, you would first meet the horse as kind of the pre-engine stage. So around this atrium, we have, or they were placed a couple of nozzles that kind of create an artificial air movement within the space. And this air movement kind of moves all the way up, or kind of moves the smoke all the way up. which is then being extracted in the top, in the center of the space. What this generates then is on one side very spectacular system. It allowed us to kind of convince the fire department that this is really a workable solution, and it also helped us to. I mean, of course, we hope that this case will never happen, that this building will never be on fire. But back then, it also kind of created kind of a question to the regulation in the sense of what are the new ways of thinking about these regulations. As my next project, which basically occupied half of my architectural career when we started it in 2008, is Raffles City in Hangzhou, which is also looking at it retrospectively is a bit kind of from, let's say, 2012 in that sense, in terms of, or let's say in terms of formal approach to a building. So it's let's say it's one of the older principles or design attempts and design intents as we have still been following at the end of the last decade. So it's located in Hangzhou. It's quite or let's say up to today, it's still our biggest project with 400,000 square meter of space. There's anything is in there that you can imagine. So it's basically a city in the city, 2 towers of 250 meter, and we started this in 2007. So it was just after my graduation, basically. And we delivered it in 2017. Looking at the program mix, I had mentioned it already. It is really, literally a city in the city. There's nothing in there that you can imagine. There's nothing in there. And for today, what I would like to throw a little focus on is how we actually have developed the envelope of this animal. I was talking about the elephant in the beginning, and how we have to chop it up in pieces in order to progress with the design work and also get it onto construction. So there was a certain process of decomposition. After, like, we had formulated the concept, we had unified the plots, we had organized the program, all the flows and everything. The massing was there. The main gestures have been designed or defined. We kind of had to break down the facades in different components, and based on that, we also had to let's say deliver certain strategies how we can approach it digitally and technically. So we look at it, again, retrospectively as a non-linear design process where you actually come with a bold idea. I have shown this before, the Mercedes-Benz Museum. You have this plate with a sketch on it, but you need to kind of bring this onto site, and you need to think of all the processes behind it in order to talk to that Chinese contractor that can then in the end build it. So we have this design intent phase where you, of course, you can think more boldly. I was talking about the resolution. This is where you spin the ideas. Next stage, the design development stage, and then you kind of circle this through the engineering and documentation to construction. So what we had done back then is we had developed a kind of a parametric toolkit for this. So for each of the facades, there's a certain process for particular stages of the design, and this we had to really do case by case. So I want to throw a little light on the urban facade, which we call urban, or we called urban facade because it's literally facing the urban context, and it kind of has a nice contrapposto gesture, unifying, or let's say moving the flows from the urban placement along the tower. And how we did this back then, in the first stage, and during the design intent stage, we were simply just modeling in Rhino by hand. It was in the beginning of the Grasshopper plugin. So there was a lot of kind of intuitive form finding process and so forth. In the next stage, we have further kind of developed our toolkit by actually programming. Back then, still VB, Rhino script, Excel, very powerful tool. We still use it today. And then what then came into play, there was still a lot of discussion about what is the right way for BIM and how can you really kind of move forward with this. So we were experimenting a lot with different software packages. And for this beast, we actually started to use Digital Project, which was back then basically an architectural top-up onto CATIA. It was kind of, initiated by Frank Gehry. So he he set up a company for that in Paris, headquartered in Paris. It's basically, let's say top of the bill, but also like a very complex piece of architecture that needed a lot of kind of expertise that we had to bring in order to do this, because we were just stupid architects back then and not really programmers. And then in the end, this kind of turned out a lot of data that we could use to really formulate geometrical data that could be used to start construction. When you look at the main parameters, I have a little video. If you think about this high-rise tower, you have a lot of stacked program. There are a lot of parameters that play into it, like the floor-to-floor height. You saw that the tower is actually wider in the bottom and more narrow in the top. So we also needed to play with different glass width. We wanted to have it three-dimensionally curved, so we had tilting, turning in different directions. Floor packages. In the bottom, for example, you have offices. In the top, you have residential. So you also need to consider how do you kind of react to that. Sun shading, very important for Hangzhou. We have external fins on the outside, which kind of need to correspond to our design intent, but also kind of have a certain thermal performance, rotation, and so forth. So this was kind of a very primary set out of the main parameters, which we, back then, I mean, we still do this today, of course. We always kind of try to prove our concepts in physical models, just as simple as that. Very early analysis, the exposure and radiation of and along the way, we already started to do material optimizations, because the client basically told us, okay, that's a great idea, but it's nice that you want to hang this element on the outside, but it uses a lot of material. So just by using, let's say, intelligent processes, we were able to really reduce and cut back the material by 50%, so we could keep our fins, and the client was happy. You see here before and after how this was kind of improved along the way. We are still in the Rhino stage, where we were still internally programming this ourselves, setting up the infrastructure for the project, the digital infrastructure. Just an impression. So when we started this, this is one of the first lines of code that were written for the script. It ended in a lot of more lines of code in the end. But it's basically a very early intuitive process, just subdividing, iterating, and kind of trying to find the best kind of logic how to really panelize the surface. I can show you this early application in action. So it's literally just like height coordinates. You set out the levels. You have certain insertion points. We have defined the components. Components always exist they are built up of two glass panels, and then we have combined this with a shading device on the outside, and this always directly linked to Excel, so that we can really read the data and also analyze it at the same time. This is what I had described before. This was, I mean, you have to imagine back then, this was actually the first kind of, let's say, step into the history of modeling. So back then, when we were still kind of working very intuitively in Rhino, you model something, and there's not really a history and a path to it that you can go back and forth. So this was very new to us, the concept back then. Working with this digital project, the top-up of CATIA, is to understand that you actually need to start from the very, very first point, and you need to build it up with a certain logic and algorithm on top of that. But you can also move forward and backward. But this back then allowed us to extract a lot of data from our model. And so when we started to look into the urban facade, we had to really break it down into certain parameters, because again the client came back to us, okay, it's wonderfully how you have designed this, but really on site we cannot really bring this, because all the details are different, all the mullions have different angles, and we need to do like 900 different aluminum extrusions in order to for the facade contractor to build it. So we need to kind of dive in, and per each element we needed to really break it down and decompose and kind of see, okay, where can we optimize, where can we use the computer to kind of be intelligent for us, and kind of find a sweet spot in the detailing. So there's a set of parameters that we have defined and identified. And if you look at this was our way of working. So this is one example where we actually have optimized the angle between two kind of adjacent panels. We started really from 900 something different angles, which is something you cannot really accommodate anymore with certain tolerances in kind of let's say the mullions between these elements. So we had a lot of let's say algorithm instantiating these units, and they were then in kind of optimizing or kind of finding this sweet spot, which is kind of represented in the Excel sheet. So this was something that we looked at for a very long time in the way of kind of how can we really optimize it, and what can digital project do for us, and how can we bring in the intelligence so that we can program it in the most efficient way. So if you look at it on the lower right, you basically see what we came up, or what it kind of ended up with. So we managed to break down 900 different details that were needed before we started this process into 8 different angles that could be, or that the tolerances in between these elements were able to accommodate. So this is something that is very, very manageable for a company to build and to produce. But then, of course, this is only one part of the whole chain, because then there's not just an angle in between two elements, but also inside the element you have the same angle, same game, you try to optimize it in the same way. And all these different parameters, they're of course nicely interrelated, and they all kind of want to be talking to each other. The same goes for glass optimization. I mean, we know as soon as you like cut a glass piece on one side, you pay extra, so we need to make sure that we can use as much as possible regular panels. For the fin, it was kind of the same logic. We had this transition along the tower, so we wanted to kind of course, make it as gradual as possible. But there were also, again, certain parameters linked to it. Like the fin depth, we had certain thermal performance that we needed to reach, which was all solved by one depth based on our analysis. Fine, so first checkpoint. Second is the fin width. Also there, the tower is wider in the bottom and more narrow in the top. So as you can see in this Excel file, we came up with, or we had to, or we could comply to the thermal performance with like just 4 different width or panel width. And yeah, as you can see here, this is kind of how it flows then along. And we always kind of proved our concept by mock-ups. Something that we truly believe in is something you need to build one-to-one mock-ups to truly understand the detailing and the way you want to move forward in your digital strategy in order to really progress and build the full building on site. Give you a little bit of an idea. And this is something that we, again, something that we could not really anticipate in 2007 when we started this project, is the way how you look at buildings. Of course, I mean, with a building with 2 towers on top, you will be able to look down. But nowadays, we are designing the 5th facade, of course, which you can now see due to the drone photography and film footage. So it's really something that we had to make sure that there's also, not too much of technical area exposed to be seen from top, and so forth. So you need to look at, or back then already, we needed to kind of look at it from all sides. I want to move forward to, let's say, the adaptivity and kind of how often it is very underdeserved need. You need to prepare for the future, and you need to, of course, speculate. Because if you are adaptive, and if you can act on or think on your toes, you can actually solve anything, I would say. So we always, at UNStudio, we mostly think in kind of systems and, of course, components, and I think we will hear much more about this today. But basically, design has to change in each of its parts and disciplines, so that we can really kind of spill over and kind of think continuously in our design process. When we started, or we did a competition in 2012 for the Doha metro network, which was supposed to cater for the World Cup. There was nothing, basically. There's nothing there. And not even the tunnels back then. So we were supposed to make a design for 32 stations in the first phase, and then up to 72 stations in the second phase, which is, of course, something you cannot really comprehend as an architect, to design so many stations. So we came up with the idea that we can actually make a manual. So when you nowadays go to IKEA, you get this like nice manual, so you know in a generic way how you can build up your tools. So what we did back then, we did the kind of a reference design. So we designed everything from really the large shelter on the outside to the trash bin on the lower right. And this was eventually handed over to 5 contractor consortium in order to construct this. So how do you do this when you think of something, a design, and you need to tell 5 different conglomerates in the end how they have to build it, that all the different stations and all the different locations will kind of comply to your design intent, because we were responsible for the overall design. So you have to make a manual. I don't want to flip with you through all these pages, but I want to give you a quick impression of what this meant. It's a bit of a fast video, so I hope if you have a weak heart, you should close your eyes for a moment. So the main challenge here was really to kind of, you need to think of a geometric rule that everybody can understand it. Or let's say that the contractor was able to understand it. The architect of the contractor was able to interpret it according to our idea. And then this across 5 different architects. So how do you describe something that doesn't allow for any mistakes? That was basically the biggest challenge. It's really like writing a manual was for us really a big challenge, but it really allowed us to comprehend and to kind of get our design intent across. So the first stations just opened recently, and it looks very convincing. So I think we succeeded in making a manual. It was our first time, and now we take this into our design process, thinking of in a way how we can kind of explain our ideas or convey our ideas in a very explanatory way. When we look at our design processes, we of course start from the main objectives in the beginning. So this is kind of where, where do we want to go with this? What is the most important parameters that we then kind of break down in the next stage? There's always kind of a calculation component to it. And for this calculation component, you also kind of develop a strategy that kind of then fuses into this overall model. And then we mostly kind of iterate within this and try to further optimize this. There are, of course, hard and soft parameters. So there are parameters that are more difficult to quantify, and then there are parameters which are more easy to quantify. We do this in very intuitive. Oops. Does it play? I'm sorry. So we do this in very kind of visual ways, very intuitive ways, that we get direct feedback from our design models. We also do this with algorithm, or let's say solver solutions. But it's not just that the solver is really solving our design issue or our let's say main question to the project. It's really about optimizing within our big idea or the bigger idea. And we also do this on the urban scale. So this is a project that we just have recently delivered the schematic design for. It's a fairly interesting project because it's literally bringing what you know from the mountains, from the ski areas, bringing the cable cars into the city as a way of urban or public transportation. And this is not just, or this was not just supposed to be a, let's say, a gimmick or a tourist attraction. It was really about to be robust and kind of live over 50 years, up to 100 years, to really build or provide a solution for the public transport needs for the city of Gothenburg. It's quite a daring or kind of a pioneering approach for a city to approach something like this, but we were quite excited that we got selected to follow up with this project, because one of our main interests is always within mobility and urban infrastructure. So when we started to work on this project, we looked at the city of Gothenburg, and what is quite apparent once you are in the city, which is a harbor city, are all these cranes that you can see all along the riverfront. So it was something very inspiring. The dynamic movement, the way the crane looks in the morning and how it ends up in the evening. So this was kind of, we took this as a pickup line for our tower design, to kind of really, let's say, build something into the skyline that has some kind of relationship to what is there already, but also that it's not really kind of becomes a strange object in the skyline, but at the same time it gives us a contemporary twist in the way how we can interpret this. So we started from very simple barbecue stick models, just to follow up with an idea, developing the geometry, which is kind of a monolithic kind of, let's say, primitive geometry that is assembled in a particular way, and we had to kind of further break this down and decompose into additional components. What was quite crucial here, when you look at the let's say the whole track of the cable car, is that we needed to implement a certain scalability. So these towers had to grow, and then you can imagine in terms of efficiency, if you want to make it really efficient for construction, you need to think of repetition of elements, components, and how you want to assemble them. When you move with these towers through an urban context, you need to or you need to deal with a lot of flexibility. So sometimes it's sitting on the water edge, sometimes it's even within traffic, sometimes it's just sitting on the side of the road. So there needs to be a lot of flexibility in the way how we can place these towers and how we can set them into the ground. And of course, we also had a certain design intent. So in the end, it's not a crane, it is a tower, and there's a lot of dynamic and static loads that needs to be need to be get under control. But we also had a certain, let's say, angle we wanted to look at these towers. So within the system, we also developed quite some flexibility. Modularity, I've been talking about this. This is really important. We started actually with a funny idea because we wanted to make these towers from concrete. So there is a company in the south of Germany, they do spun concrete. When you drive along the highway, so you usually see these big poles where they hang the IKEA sign or the Golden M for McDonald's. So these kind of big, like 30, 40 meter high poles, they're mostly made from spun concrete. Spun concrete, you can imagine, is like you put a rebar into a long tube. It's mostly welded with a robot. And then this tube has two halves, so one bottom and top, so it's kind of a mold. And so you have this long tube, you fill in the concrete, you close the tube, and then you start spinning like a washing machine. So what this allows is it creates a very high density of the concrete, and you get very, very thin cross-sections. So this was our idea in the beginning that, okay, let's try this because you don't need to maintain it. We are in a harbor city, we're close to the ocean, there's salt in the air or that can kind of lead very quickly to corrosion. So we kind of had the idea that this is very good in terms of maintenance and also life expectancy of these structures because they needed to be laid out for like 100 years. So but then we had to come up, because it's a mold system, so it's a kind of a cast system, we need to come up with a certain logic and repetition in how we can make this in order to be cost efficient. Unfortunately, I have to disappoint you because in the end it turned out to be steel. Because just from economic standpoints, it was not really feasible to just deal with one company and drive all these 30-meter long columns from the south of Germany all the way up to Gothenburg. So, now we look at steel, but still the logic and the initial ideas are still in there. I think I'm running out of time. So I want to wrap this up with maybe the most crucial piece in our practice or in our nowadays in the challenges that we face is that we do everything in collaboration. This is already how UNStudio was initiated at the end of or in 1998. It's kind of a united network. It's the way how people work together. And you could basically say that collaboration is very unnatural act between unconsenting adults. So there are a lot of terms flying around, like the collective impact, aligned actions, social impact networks, multi-stakeholder partnerships. So I think you can call this in many, many ways. But what is at the end of the day, you kind of need to make the we work, because you kind of need to make the we work in order to build like really smart and collaborative relationships so that you can move forward efficiently on the long haul. How we do that, we are a knowledge-based company, so we truly believe in research that on one side we have to conserve the research that we do, and also kind of how we need to develop new domains. And therefore we have a very broad kind of setup. Of course, our cash cow is architecture, so this is still our main branch. But nowadays, we're not kind of the classic architects and designers anymore. We have a future department where you have a job position that is called futurist. It was also not really something I was familiar with, but those are very, very interesting people. We work on interiors, we conserve our knowledge, we develop products in order to be scaled up on a larger scale, And on a larger scale, we also work in the urban realm. And we have heard that before, the link between architecture and technology. We even have founded a company, let's say a new business model that is really dealing with digital and sensorial technologies and how we can kind of integrate this into our buildings so that we can actually make more sensitive buildings and that they can react and adapt to individual needs. When we look at this, so we always try to design a toolbox in order that we can enable our ideas to become reality. We're also designing a lot of technology. But basically we work in a team of teams, and this is the most important. So it's really the composition of how you bring the right expertise to the table and how you can develop this toolbox that you would need to make the next step. And we should never underestimate the cultural impact that we have. Looking at this bridge, which was one of our first big projects, 1992 it started. I want to close this my presentation with this beautiful tattoo on this back of this man. And the anecdote behind this is that he's a captain on a ship living in Rotterdam. And every time he comes back to Rotterdam and he goes under the bridge, under the Erasmus Bridge, for him this is a signal that he's home, so that he arrived in the place to be. And he loves this so much that he had to put it on his back. And I think this is something that is you could not get further to a person by under his skin. It's something that we very, very much like. Is like, how do we move people and how do we touch people and how do we kind of improve the lives of people? Thank you very much.